Greetings of the day. Today I am going to discuss about the lottery scheduling code in operating system. Lottery scheduling. Previously we discussed the schedulers in the terms of turnaround and response times. This time we want to look a scheduler that dictates that each job gets a specified percentage of CPU time. This is why it is called as an fair share scheduler. Sometimes lottery scheduling code is called as an fair share scheduler. Let us will go to this discussion introduction. Lottery scheduling is a type of process scheduling, somewhat different from other scheduling like round robin, first come first service and priority scheduling. In lottery scheduling, processes are scheduled in a random manner. Lottery scheduling can be preemptive or non-preemptive. It also solves the problems of derivations. In lottery scheduling, it can be preemptive or non-preemptive manner. Give each process at least one lottery ticket guarantees that it has a non-zero probability of being selected at each scheduling operations. In this scheduling, every process has some tickets and the scheduler picks a random ticket and process having that ticket is the winner and it is executed for a time slice, and then another ticket is picked by the scheduler. For example, you are taking to this 100 tickets, between 0 to 199 tickets you are picked the one ticket. Each ticket have to the schedule and it is then time slice. These tickets represent the share of processes. A process having this higher number of tickets give it more chance to get chosen for execution. For example, a process having to this high number of tickets, it more chance to get them chosen execution. Assume there are two processes A and B. If we have two processes A and B having 60 and 40 tickets respectively of 100 tickets, the CPU share of 60%. If you have two processes A and B having 60 and 40 tickets respectively out of total 100 tickets, CPU share of 60 and that B is the 40, these are share calculated by this probabilistically and not deterministically. The operating system periodically every time slice, for example on the above example, holds a lottery. In order to this, the scheduler needs to know the total number of tickets. In the above example, there are 100 number of tickets are there. For the allocation of this each process A and B, process A allocating 60 tickets and process B allocating 40 tickets. For our example, we have two processes A and B. A has 60 tickets, the ticket number 1 to 60, and B has 40 tickets, ticket number start will 61 to 100. The total process A and B having 100 tickets. Scheduler picks a random number from 1 to 100. If the picked number is from 1 to 16, then A is executed, otherwise B is executed. In the above example, we have two processes A and B. A has 60 tickets. For example, the CPU picked the ticket number is the 59. Process A has to be executed. If the CPU picked the ticket number 70, the process B is to be executed. An example of 10 tickets picked by the scheduler may look like this follows. For example, here is an example of lottery scheduler results as it holds the series of lotteries. First you are taking to this ticket number in the between 0 to 99, which is then resulting schedule. Is that resulting schedule of B, ticket number 73, 82, 23, 45, 32, 87, 49, 39, 12, 9. These are the random numbers you have to generate, and you can the CPU picked that random numbers. In that random number, the resulting schedule is, if we have picked the 73 randomly, the B process has to be executed. If you have picked the CPU, picked the ticket number is 82, B process has to be executed. Ticket number 23 picked by the CPU, the process A has to be executed. The same like as then process A and process A, process B, process A, 39 is then process A, 12 is process A, 9 is then process A. A is executed 7 times and B is executed 3 times in the above example. As you can see that A takes 70% of the CPU and B takes 30%, which is not the same as what we need, as we need A to have 60% of the CPU and B should have 40% of the CPU. This happens because sets are calculated probabilistically, but in the long run, when the number of tickets picked is more than 100 or thousands, we can achieve a sheer percentage of approximately you have taken to this 60 and 40 for A and B respectively. This is the ticket mechanisms. In the ticket scheduling, there is a ticket mechanism. There are the 3 types of mechanisms you are influenced by this for this lottery scheduling. The tickets can be manipulated in the variety of ways. Here are some common example of ticket mechanisms. There are the three mechanisms you are in the lottery scheduling. The first one is then ticket currency, second one is then ticket transfer, and third one is then ticket inflation. The first one we are going to discuss the ticket currency. In this lottery scheduling also allows for this manipulation of tickets in the various occasionally effective ways, including the ideas of ticket currency. For example, the system issues a set of number of tickets to a user. The user can then issue the tickets to their own jobs in a different currency. The operating system can convert the different currencies back to these global currencies. For example, in the below example, the user A, B, you have to allocate the job A1, A2, B1. The user currency you are using into this ticket currency 500, 500 and 10. That will be converted into this global currency. The number of tickets has to this total is then 100. The user currency indicated then 10. It will treated as then 100. For example, the system issues 100 tickets to both the user A and B. User A runs 2 jobs and they assign each job 500 tickets. See, in the below example, A1 500 and A2 500. In that above 1000 possible tickets. Similarly, user B has 1 job perform and they assign 10 tickets to the job. Out of 10 possible tickets, each user created their own currency to handle their jobs. Each job have to create then their own currency that called as then global currency. User A1 having 500 tickets and user A2 having 500 ticket, that will be converted into this global currency. User A1 process A1 allocate the converted the currency then 50 and A2 converted into this 50. While this may seem confusing, this operating system can convert these currencies back into this global currency where each user has to this 100 tickets. Ticket transfer. The second mechanism is then ticket transfer. This ticket transfer mechanism means a process can temporarily give to the ticket to this another process. For example, this common with then client server relationship. The client generates the ticket for a job but then sends them into the server which handles the request and send the tickets back to this client. Ticket inflation. The third mechanism is ticket inflation. Ticket inflation is the mechanism that allows the process that temporarily increase or decrease the amount of tickets it holds. Inflation can be used in the situation where mutual trust exists between to this process. For example, process A and process B. Even there is the mutual trust exists between to this process A and process B, there is a chance to inflation. If a process needs more CPU time than allocated time, for example, process A allocating the certain time period, it need more CPU time utilization. There is a mutual mutual trust between exist between to this process A and process B. It will take the CPU time, it can boost its tickets value without having to this communicate with any other processes. This is the code I have to implemented in the ticket lottery scheduling. Int current ticket initially have to initialize then for this ticket for a job. The simple code have to left the provide the more concentrate example of this one. There are the variables to keep the track of this current job. The winning the tickets is then winner, and the image largest ticket of this current job is the current ticket. As the program run, you have to this winning of these tickets, there are these 300 and the current ticket into this 100, and the complete the job is to be the job allocation. The node T current job is equal to head, that job has to be assigned into the 300 tickets, while current job, the current ticket equal to current tickets plus current job is greater than to this tickets, that is called the larger tickets. Since current ticket is then 100 is the less than winner 300, the current between to this job B and current tickets become to this 50. Current ticket is once again less than the winner, the current job becomes to the job C. You have to this the find to this exist into the loop. The current ticket is the greater than the winner, then you can take the break command, and lottery winner is found to be then exit. When the greater than to this ticket, the command has to be executed and it is found to be then execute loop, and you can break out of the loop. The value of this current job is the lottery winner. Whatever the present in this example, how to implementing the lottery scheduling requires to have a quality random number generator. For example, you can take then job A, job B and job C. A data structure to keep the track of system processes, the total number of tickets available. For example, in that example, we are taking to this 400 tickets. For job A allocating 1 to 100 and job B allocating from this 101 to 150 and job C allocating to 151 to 400. In the beside the diagram, there is a head and there is a null. There is a winning number you have to indicate. This animation shows what a lottery winning process would look like. A job has A has tickets 1 to 100 and job B has tickets 101 to 150 and job C has tickets 151 to 400. The system chooses a random number between 1 and 400. 300 in this case, since 300 falls into the block of tickets for job C. This job wins the lottery. In the above animation, there is then job A 1 to 100 tickets and job B 101 to 150 tickets and job C 151 to 400 tickets. The total number of tickets are 400. In the between 400, the CPU picked the ticket number is then 300. Job C winnings for this lottery. Thank you very much.